Fractions and decimals. To change a fraction into a decimal, divide the denominator into the numerator with long division. Let's look at an example. We will change 2/5 into a decimal. So we're going to have to write it with a long division grid, 5 into 2. The order is very important there. Right. 5 won't go into 2, so you're going to have to put a decimal, take it straight up, and then you're allowed to add zeros after the decimal. Now we can divide 5 into 20. It will go 4 times. Multiply back, 4 times 5 is 20. So our decimal equivalent to 2/5 is 0.4 or 4/10. This is a terminating decimal because it ends without any remainder. Let's look at another example. We will change 5/6 into a decimal. So we're going to need to divide denominator into the numerator. So 6 into 5. And 6 won't go into 5, so we'll put our decimal, take it straight up, and then we're allowed to add zeros. So we'll divide 6 into 50. This will go 8 times. Multiply back, 8 times 6 is 48. Subtract. We can add another 0 and bring down. 6 into 20 will go 3 times. Multiply back, 3 times 6 is 18. Subtract, add another 0 and bring down. 6 into 20. This is going to go 3 times. 3 times 6 is 18. And we're going to start to realize here that every time we're going to get a remainder of 2. So we're going to continue getting this 3 up here. This one is called a repeating decimal. The 3 is the part that's repeating, and a common way to write it is with a bar over the part that repeats. You don't want it over the 8 because the 8 is not repeating, but the 3 is. So you just write the first digit that's repeating and put the bar over it. A repeating decimal has a digit or digits that repeat in a pattern. Let's look at one more example. We will change 9/11 into a decimal. So we're going to have to do 11 into 9. It won't go, so we put a decimal, take it straight up, add some zeros. So we'll do 11 into 90. We'll go 8 times. Multiply back, 8 times 11 is 88. Subtract, so 10 minus 8 is 2. Add a 0, bring down. 11 into 20. We'll go 1 time. Multiply back, 1 times 11 is 11. Subtract, add a 0, bring down. 11 into 90. We'll go 8 times. Multiply back, 8 times 11 is 88. Subtract 2, add a 0, bring down. And 11 into 20. We'll go 1 time. Multiply back. And what you notice is you're getting a pattern, but it's not just 1 digit. It's repeating in 2 digits. So our repeating decimal here is going to be 0.81, and we'll put the bar over both because that's what is continuing to repeat. If they're only asking you in the problem to change the fraction to a decimal, write it with the bar over the repeating digits. If you have to do some other math calculation with it, though, you would need to round because you can't calculate with the bar there. So if we had to do a calculation with this decimal, we would need to round, and if it didn't specify to what digit, we could choose. If we wanted to choose where it starts to make the pattern, we could round to the nearest hundredth. So for the hundredth, the 1 is in the hundredth place. Look to the right, the 8 would push it up. So since we're rounding, I'm going to use a wavy line because that means it's approximate. And that would push it up to 2. So 0.82 if we had to do some math. Or we could have rounded to the nearest tenth. To the 10th, the 8 is in the 10th place. A 1 would drop off, so it would be just 0.8. We could use either of those to do a calculation. We often have to have the same kind of number to be able to do math or compare. Let's look at an example which we've done before, where we're going to choose the correct symbol, greater than, less than, or equal to. And this time we have both decimals, so we can compare those for size. So we match digit to digit. So 0 to 0 is the same, 9 to 9 is the same, 8 to 8 is the same, and we have a difference in that third digit. So the 8 is larger, and we can choose. Let's look at the following example, though. We're going to do the same thing, choose greater than, less than, or equal to. And we have 5/9 compared to 0.557. It's not easy to tell which is bigger. We need the same kind of number. And normally it's easier to go to decimals because if you get fractions, then you have to get a common denominator to compare. So we will switch the 5/9 to a decimal. So I will do that on the side. 9 into 5. Won't go, put my decimal, take it up, add some zeros. So 9 into 50 will go 5 times, multiply back. 5 times 9 is 45. Subtract, add a 0, bring down. 9 into 50 is going to go 5 times. 5 9s are 45. So we're going to start to realize here, this is a repeating decimal. We're going to keep getting 5s forever. So our 5/9 is 0.555, and it continues with 5s. But you want to compare without rounding, so you need go ahead and put as many digits as you have to compare. So we're matching 0 to 0 is the same, 5 to 5 is the same, 5 to 5 is the same, and we have a difference in this third spot. 7 is larger. It doesn't matter that this one continues. The 7 is bigger than that digit, so we have our answer. But this is a place where we had to convert our fraction over to decimal so that we have the same kind of numbers to work with.